Math 95, Quiz 6 solutions. We're asked to simplify this radical by leaving the stuff in the square root sign as small as possible. Take as much out as you can, I guess, is one way to think about it. I think how I would approach this is I'd first figure out the prime factorization of 72. There's a few ways to come up with that. I think what I would see is that's 9 times 8, and 9 is 3 times 3, and 8 is 2 times 4, which is 2 times 2. So 72 is 2 times 2 times 2, 2 cubed, times 3, 3 squared. So I would think about this problem like I'm trying to take the square root of 2 cubed times 3 squared times x to the 5th times y squared times z cubed. And the way I simplify this is I say, okay, that equals, and then I make two different square root signs. Let's see, I think in class we called one of these the good one, and one of these the bad one. And what I put under the good one is all the things that will end up being perfect squares. So first let's take care of the 2. 2 cubed. Well, let's see, I could put 2 of the 2's over here, 2 squared, because that's a perfect squared, and then the other 2 over here. 3 squared. Put them both over here, which leaves nothing in the bad. X to the 5th. You could put x squared over here and leave x cubed over here, but you can do even better than that. You could put x to the 4th. You could stick 4 of them over here because that's also a perfect square. And the last x over here. Y squared. Stick them both over there. Z cubed. You can stick 2 of them over here and the other one over here. And so if you understand why you put all those there, I guess the reason why is because all this is a perfect square. The square root of 2 squared is just 2. The square root of 3 squared is just 3. The square root of x to the 4th is x squared. Square root of y squared is y. Square root of z squared is z. And then this bad radical is the stuff we can't touch. Just leave it like that. We can actually go one step further. Instead of 2 times 3, might as well call it 6. 6x squared yz times the square root of 2xz is the final answer. All right, moving on to the next problem. Okay, another just big mess that we're asked to simplify. See, a couple different ways to do this one. I think the way I see it is I first see what's inside these top parentheses, x to the 1/2 times x to the 2/3. So I have the same base and different exponents. So what I want to do is add the exponents. So what I need to do is add 1/2 and 2/3. See, the way you add those, you need a common denominator. You need to multiply this by 1, but what one of the other teachers called a fancy form of 1, and multiply this by 1, or maybe a fancy form of 1. This right here is 1, this right here is 1. But by choosing 3 over 3 here and 2 over 2 here, what we're left with is 3/6 on the left plus 4/6 on the right, which is just 7/6. So by doing all this work over here to the side, what we end up with is this thing right here is equal to, instead of x to the 1/2 times x to the 2/3, it's x to the 7/6. Right, 1/2 plus 2/3 is 7/6. And all that is squared, and that's divided by x to the negative 2/3. But we can do more. Let's see, now we have an exponent raised up to a power, a power raised up to another power. This raised up to a power raised up to another power. So our rule for that is we multiply these two guys. So we have to multiply 7/6 times 2. If you forget how to do that, it helps to think about it as 2 over 1. Then you multiply straight across, you get 14 over 6, which reduces to 7/3. So what we have up top is x to the 7/3 divided by x to the negative 2/3. And we can do one more step. Let's see. Okay, so there's two ways to think about it. Either you can be like, we have the same base here, And since it's dividing, we want to do 7/3 minus negative 2/3. Or kind of the way I like to do it, maybe I'm just kind of strange, is I don't like to see fractions at all. So I like to put in an extra step because it makes it easier for me. I don't want to have this x in the denominator here. I want to move it up to the top. And I know that the way I can move something up to the top is by getting rid of the negative in the exponent. So instead of x to the 7/3 divided by x to the negative 2/3, we can call it x to the 7/3 times x to the positive 2/3. And I like to do it this way because for me it's easier to add numbers than to subtract. 7/3 plus 2/3 is x to the 9/3. And then you're like, oh, 9/3, that's just 3. So isn't my answer just x cubed? And I would say yes, it is. That is the final answer. And that is the end of the quiz.